Good day everyone, I am Ma'am Jenny, your science teacher, and in this video lesson, we will discuss about the subatomic particles and how to determine the number of protons, neutrons, electrons, atomic mass, and atomic number using the periodic table of elements. Before we discuss our new topic, let us have a review of what we have learned, which is about atomic models and theories. So on the first column, we have the name of the scientist, and on the other side, we have the name of the models. Okay, here's the answer. Sir Ernest Rutherford's model is the atom's massive center. Quantum mechanical model was proposed by Erwin Schrödinger. The planetary model was proposed by Niels Bohr. J.J. Thomson's model is the plum pudding or the raisin bread model, while the indivisible atom was proposed by John Dalton. These scientists are responsible for the development of the atomic theory and models. On this video lesson, we will determine the number of protons, neutrons, and electrons in a particular atom. But before we discuss, let us have this information about some properties of the three main subatomic particles. So we have the electrons, protons, and neutrons. The charge of electron is negative, and the charge of proton is positive. So we have here their masses and the location in the atom. Now, to help us understand this data, let us try to answer the following questions. Number 1. Which subatomic particle is the lightest? The electron. The electron is the lightest subatomic particle. Which subatomic particle is the heaviest? Our answer is neutrons. And number 3, which subatomic particles have almost the same mass? If we're going to take a look on this data, so we have protons and neutrons. I know that you are familiar with the periodic table of elements. What are the informations that we can get from this periodic table of elements? Here are some of the informations that we can get from the periodic table of elements. We have the name of the elements. We can get there the symbols, mass number, atomic number, and a lot more. At this point, let us have an activity. The objectives of this activity: locate the atomic number in the periodic table, identify the subatomic particles associated with mass number, and determine the number of neutrons from the mass number. Materials that we need: paper, pen, and of course, periodic table of elements. First question. What is the element with an atomic number of 15? So you have here the element with an atomic number of 15 is phosphorus. The atomic number of the element is located on the upper left part or left superscript. How many protons does the atom of this element have? The answer is also 15. Each element has distinctive number of protons. The unique number is known as the atomic number. So therefore, we can say that the proton or the number of proton an element has is the element's atomic number. For example, phosphorus atomic number is 15 because it has 15 protons. Silicon's atomic number is 14 because it has 14 protons. How about sulfur? How many protons are there in sulfur atom? If your answer is 16, then you are correct. It represents the number of electrons in the same element. Remember that In Thomson's model, the number of proton and the number of electron is equal. So therefore, if the number of proton is 16, the number of electron is also 16. Take note, that is only true for neutral atoms. All atoms of a given element have the same number of protons and electrons. All atoms of a given element have the same atomic number. Sodium atom's atomic number is 11. The atoms of different elements have different number of protons as well as atomic number. So if the atomic number of an element is 12, it is no longer sodium but magnesium. If the atomic number of the element is 13, then it is no longer magnesium but aluminum. Question number 3. How many protons are there in an atom of aluminum? So again, the atomic number of the element is the number of proton an element has. If the atomic number of aluminum is 13, we can say that aluminum has 13 protons. Number 4. Which element has the smallest number of protons in its atom? If your answer is hydrogen, then you are correct. As you can see, on the upper left side of the periodic table of elements, we have here the element with the smallest number of protons in its atom, and that is hydrogen. Its atomic number is 1. For a neutral atom, the number of protons is equal to the number of electrons and equal to the atomic number. Therefore, for a neutral atom, the number of proton is the same as the number of electron and its atomic number. Mass number, for us to get it, is number of protons plus the number of neutrons. Again, mass number is proton plus neutrons. While for us to get the number of neutrons, we have the atomic number minus the mass number. Again, this is only true for a neutral atom. Let us have this one. Lithium's atomic number is 3. Its mass number is 6.941. If we round it off, we have 7. The number of proton is 3 because it is the same with atomic number, while electron is 3 because it is same with proton. For us to get the number of neutron, 7 minus 3, then we have 4. Another example, we have the magnesium atom. Can you tell what is the atomic number of magnesium? If your answer is 12, then you are correct. Mass number of magnesium is 24.305. Then if we round it off, the answer is 24. How about the number of proton? Very good. The answer is 12. Why 12? Because the number of proton is the same with the atomic number. How about the electron? Very good. It is 12. Why 12? Because the number of electron is same with proton. For us to get the number of neutron, mass number minus number of proton, so we have 24 minus 12, then the number of neutron for magnesium atom is 12. Then we have the aluminum atom. What is the atomic number of aluminum? If your answer is 13, then your answer is correct. Its mass number is 26.982. Then we round it off, the answer is 27. The number of proton is 13 because remember that the number of proton is same with atomic number. How about electrons? If there are 13 protons, therefore we have 13 electrons because it is same with proton. For the number of neutron, we have 27, which is the mass number, minus 13, which is the number of proton, then we have 14. For us to check if you have learned about this, let us have an exercise. All you have to do is to fill out the table below. So you have here the elements carbon, arsenic, potassium, and platinum. Okay. Let us have the answer. If you got a perfect score, then congratulations. Let's move on. While the number of protons is the same with atoms of a particular element, the number of neutrons may vary. Atoms having the same number of protons but different number of neutrons are referred as isotopes. The isotopes are identified through their mass number, which is the sum of the number of protons and the number of neutrons in an atom. For example, calcium has 24 isotopes. 5 stable isotopes and 19 radioactive isotopes exist, ranging from calcium 34 to calcium 57. A shorthand notation for isotope includes the element's symbol and mass number. For instance, calcium 40. We can say that this is an isotope of calcium 40. Consider these two isotopes of carbon, carbon 12 and carbon 13. How many protons are there in carbon 12 isotope? How about the number of neutrons? How many protons are there in the carbon 13 isotope? How about the number of neutrons? Okay, let's try to answer. Carbon's atomic number is 6. Therefore, the number of proton for carbon 12 is 6. The number of neutron is also 6. To check if our answer is correct, let's add the number of proton and neutron. 6 plus 6 is equal to 12. So we have carbon 12. For carbon 13, the number of proton is also 6 because whether it is carbon 12 or carbon 13, it is also carbon and its number of proton will not change while the number of neutron is 7. So if you add the number of proton and neutron to obtain the atomic mass, you have 6 plus 7, then you have 13. So that is why carbon 13's number of proton is 6 and its neutron is 7. So aside from carbon 12 and 13, we also have carbon 14, which is a radioactive carbon that is used for fossil dating, or we call it as carbon 14 dating. So carbon 12 has 6 neutrons and 6 protons. That is why its atomic mass is 12. Carbon 13 has 7 neutrons and 6 protons. That is why its atomic mass is 13, while carbon 14 has 8 neutrons and 6 protons. That is why its atomic number is 14. Remember that the number of protons for carbon 12, 13, and 14 is the same because they are all carbon. The only difference that they have is the number of neutrons. Let us have another practice exercise for iron 54 and iron 56. Your clue is the atomic number of iron is 26. Okay, done? Since the atomic number of iron is 26, it has 26 protons for iron 54 and iron 56 because they are both iron. If the number of protons for iron 54 is 26, 54 minus 26, then we have 28. For iron 56, the number of neutron is 30. If you got a perfect score, then congratulations! Atomic mass is the mass of an atom of a particular element. It is the average average of the mass numbers of the naturally occurring isotopes of the element multiplied with their respective abundance. Let's analyze this shorthand notation of a neon atom. What is the atomic mass of neon? As you can see, the atomic mass of neon is 20. What is the atomic mass of iron? If your answer is 56, then you are correct. Why 56? 55.845, you round it off, then you have 56. Okay, let us have some exercises. So you have here the elements hydrogen, lithium, sodium, aluminum, silicon, sulfur, and calcium. Using the given elements, fill in the information needed in the table. So you have to provide the element's name, the symbol, atomic number, atomic mass, and number of proton by just looking at the element cards. Okay, are you done? Alright, here's the answer. If you got perfect score, then congratulations. At this point, let us analyze the figure. Information on the subatomic particles may be derived from this shorthand notation. The base is the element's symbol. The left subscript denotes the mass number wherein the number of neutrons may be derived. The superscript at the left denotes the atomic number. Therefore, the number of protons may be known. The superscript at the right denotes the charge wherein the number of electrons may be determined. Atoms may gain charges. This happens when electrons are lost or gained by the atom. When this happens, the atom becomes an ion. When a neutral atom loses electrons, it becomes positively charged and is called a cation. While when a neutral atom gains an electron, it becomes negatively charged and is called an ion. Let us analyze this shorthand notation of magnesium ion. How many protons are there in the magnesium ion? The answer is 12. Since the atomic number is 12, it means that there are 12 protons in the magnesium ion. How many neutrons are there in this magnesium ion? The answer is also 12. Why 12? If the mass number is 24 and the number of proton is 12, then you have 24 minus 12, then the number of neutron is 12. How many electrons are there in the magnesium ion? Take note that the charge of magnesium ion is positive 2. Since it is positively charged, it is a cation, meaning to say that the proton is higher than the number of electron. By how much? By 2. Since the number of proton is 12, then the number of electron is 10. Now let us complete the table below. So you have the isotope, the name of the element, number of proton, number of electron, number of neutron, and charge. Alright, let us have our answer. Okay, if you got the perfect score, then very good.
Atomic number is the atom's numeric identity. No two atoms have the same atomic number. The mass of the atom is concentrated in the nucleus. The sum of the numbers of protons and neutrons in an atom gives the mass of the atom.
Ions are formed when an atom gains or loses an electron. A positive ion is a cation ion, while a negative ion is an anion. At this point, let us have a short quiz. What is the mass number of an atom of berkelium that has 97 protons, 97 electrons, and 150 neutrons? A. 53, B. 97, C. 247, D. 194. Number 2. If there were 5 positive charges and 3 negative charges in a body, what would be the overall charge of the body? A. Positive 3, B. Positive 2, C. Negative 3, D. Negative 2. Number 3. Element A has an atomic number of 62 and an atomic mass of 207. How many electrons are there orbiting outside the nucleus if the atom is electrically neutral? A. 145, B. 62, C. 207, D. 269. Number 4. How many neutrons are there in an atom of iron? A. 26, B. 56, C. 30, D. 82. And number 5. What is the atomic number of calcium? A. 40, B. 20, C. 60, D. 41. Alright, let's answer. Number 1, number 2, number 3, number 4, and number 5. Komawo, annyeong, thank you and goodbye.